Our channel Elimika Mtandaoni. My name is Agustino Mogosi. We are proceeding with the fourth lecture on a series of lectures on decision and executive support systems. And today I will be discussing about data management. So we'll get to know what is data management, what are the challenges that face data management, the data sources, and we'll go into details about these sources of data. Specifically, we'll be looking at the databases. So what is data management? Speaking of data management is an administrative process. As we have said, it is an administrative process that includes acquiring data, validating, storing, protecting, and processing the required data to ensure that it is accessible, it is reliable, and it is timely. So when it is needed by the users. So when we talk about data management, we start at the first point where data enters into a certain system, that is data acquisition. So that is the first step. After data has been acquired, it should be validated if it is a proper data that should be stored. Once we find out that the data is valid, then that data gets to be stored and it is protected and processed to ensure that it is accessible, reliable, timely for its users. The data management, when we are talking about data management as a process, it includes a combination of different functions that collectively aim to make sure that the data in a corporate system is accurate, it is available, and it is accessible. So it's a combination of different functions. When you talk about data management, it's not just a simple function, but it's a combination of functions where the aim is to ensure that this data in a corporate system is accurate and it is available and needed, and it is also accessible. The main goal of data management is to help people, is to help organizations and the connected things, people, organizations, and even the connected things, to optimize the use of that data within the bounds of the policy and regulation so that they can make decisions and take actions that maximize the benefit to the organization. So as you are dealing with data, as you are managing data, you ensure that the whole process, all things that involve data, they are within the bound. They are within the bound of a policy and regulations. So we don't deal with data that do not follow regulations or they follow policy. And we do that so that we can make decisions and take actions that will maximize the benefit to the organization. Data is increasingly seen as a corporate asset that can be used to make more informed business decisions. It is used also to improve marketing campaigns. We can use data to optimize business operations and even to reduce costs, all with the goal of increasing revenue and making what we call profits. But the lack of proper data management can saddle organizations or can hinder the organizations with incompatible data. So you will have a lot of data silos that are incompatible. You will have a lot of data that are inconsistent. You will have a lot of data that have quality problems and that can limit the ability to run business intelligence and even analytics. So when we talk about data management, we make sure that we don't have a lot of data that are useless. We have data which are consistent. We have data which are in quality form. We have data that cannot limit the ability to run the business intelligence and the data analytics. So that is the big aim of data management. Challenges of data management. While there are some companies that are very good at collecting data, there are some companies that collect a lot of data. They collect this data and they do not manage them well enough to make sense of it. Collecting data is one thing, but if you want to have data that will benefit your organization, then we don't just collect data. We, the enterprises and organizations, what they need to understand from the start that data management and data analytics only will be successful when first we put some thought into how they will gain value from the raw data. So before you collect data, you have to make sure that you understand how will those data help you. How will those data help you to make some insights, to use such data to make profit, to get benefit in your organization. So they can then move beyond raw data collection with efficient systems for processing, storing, and validating data, as well as effective analysis strategies. There is another challenge with data management that occurs when companies categorize and organize data without first considering the answers they hope to glean. When I say to glean, I mean to obtain information from that data. So before you collect information, you must have some questions. For example, if you want to data that will answer a question about what will happen to the company when we double production, then from that question, there is where you can go and collect data that will particularly answer such question. So each step of data collection and management must lead towards acquiring the right data and analyzing it in order to get the actionable intelligence necessary for making truly data-driven business decisions. What's the real data management best practices? Speaking of real data management best practices, we say that the best way to manage data and eventually to get the insights needed to make data-driven decisions is first to begin with a business question and then acquire data that is needed to answer that question. So in order for you to have a good way to manage data, first you need to have a question, and after that question then you collect data that will help to make you to make what we call data-driven decisions. So you begin by a business question, then you go to the process of acquiring data that is actually needed to answer such questions. Companies must collect vast amounts of information from various sources and then utilize these best practices while going through the process of storing and managing the data. It doesn't end just with the managing the data, then it goes to the point where we clean and mine the data and then analyze and visualize such data in order to inform their business decisions. So it is very important to keep in mind that data management best practices should result in better analytics. So it's not just a collection of data. If it is, you are talking about the best practice, then make sure that data management practices must result into better analytics. And this is done by correctly managing and preparing the data analytics companies that will optimize their big data. We say a few data management best practices organizations and enterprise should strive to achieve. They include the following. The first, you have to simplify access to the traditional and emerging data. There should be a simplification of how you can access the traditional and even the emerging data. Then you should scrub data to infuse quality into existing business processes. When I say scrub, I mean you should clean the data so that you can get a quality data that you can put into existing business processes. Also, you should shape the data using flexible manipulation techniques. So these are the three important data management best practices that you can use. It is with the help of data management platforms that these organizations have the ability to gather, to sort, and to house their information, then repackage it in visualized ways that are useful for marketers. So it is very important now to look at the data management platforms. Speaking of data management platforms, what are they? When we say data management platforms, this actually is a software that is used to collect and manage data. So there are several softwares that we can use to collect data and manage such data. Actually, these data management platforms, they allow businesses to identify audience segments which can be used to target specific users and contexts in online advertisement campaigns. These data management platforms may use big data or artificial intelligence algorithms. The aim to use these algorithms is to process and analyze large data sets about users from various sources. Data management platforms are essentially platforms for housing important digital data. For example, the customer data. If you ever seen that you visit a certain business website where you find they need information about you, they collect what we call cookie IDs. They prompt you to accept them to collect some cookie ID or such kind of data. We call them customer data. Some like mobile identifiers and some campaign data. All these data are collected by these data management platforms. These types of tools also help digital roles, for example, the marketers and the advertisers, to build what we call customer segments and their performance. These segments are then built up based on demographic data, past browsing behaviors, and even location or devices, and a lot more. So here we have some examples of data management platforms that are very popular in the existing world. We have the first very important and powerful data management platform called Lotame. Actually, this one is an industry-leading data management platform. It gives users information from sources such as, let's say, email, social websites, mobile apps, customer relation management tools, the campaign data, the blogs, and more. In addition to standard features, users also have access to manual and full automated suite of optimization tools if you are using Lotame data management platform. Actually, this platform is intended for marketers, it is intended for publishers, and even digital agencies. Lotame is great for increasing engagement and unifying your data. So this tool doc, however, lacks live reporting of audience, and sometimes it experiences slow loading and time. So in order to understand about this, I would prompt you to visit a website called www.lotame.com so that you can learn and understand how this data management platform works. Another data management platform that we should be aware of, there is this what we call Salesforce data management platform. This particular product from Salesforce, it makes use of artificial intelligence and machine learning, and it provides users with the complete customer data profiles, multiple channel engagement, and it helps to engage with existing customers, as well as it can help you to find new customers. Find it under the website www.salesforce.com. Another data management platform, we call it OnAudience.com. OnAudience.com is a popular data management platform among the advertisers, in that it enables users to build any audience segment based on attributes such as gender, such as age, online behavior, interests that are very crucial to online advertising activities. The website for that is www.onlineaudience.com. We have another data management platform. Actually, there are so many data management platforms. We have this what we call SaaS data management suite. It is part of the SaaS largest independent vendor in the data management marketplace. It is very great for collecting data from legacy systems and from Hadoop. We know Hadoop is an open source framework for storing data and running applications on clusters, commodity hardware. Actually, this is a very high level software. It enables users to update data, alter processes, and do their own analysis results. So you can visit their site www.sas.com so that you can learn how this data management platform works. We have so many other data management platform software. We have one that is called the MAP data management platform. We have Cloudera, we have Nicela, we have the ADEX, the Relay 42. All those we call them data management platforms. These top performing data management platforms are actually capable of managing all of the data from the data sources in a central location, and they give marketers and even executives the most accurate business and customer information available. Now, let us see the benefits of data management and data management platforms. When you are managing your data, that is the first step towards handling the large volume of data. They can be both the structured and unstructured that actually flouts businesses daily. It is only through data management best practices that organizations are able to harness the power of their data and even gain insights as they need to make these data useful. So in fact, data management via data management platforms enable organizations and enterprises to use data analytics in beneficial ways. And here are the ways where you can use the data management and data platforms to benefit the organization. The first is using data management and data platform will help you to personalize the customer experience. When we talk about personalization of customer experience, it means that you will be able to send customer advertisements or contact customer in a specialty way, in a specialized way where you show that you understand the customer. So if it is required for a customer, a male customer, then and you are selling female staffs, then the system or the platform will automatically leave out the female staffs and deal with the male staff. You can add values to customer interaction using these platforms. You can even identify the root causes of marketing failures and business issues in a real time. You can also do the reaping of the revenues that are associated with the data-driven marketing, or you can also improve customer engagement, how you engage with your customers, and even you can increase customer loyalty. So those are the benefits where data management and data management platforms provide. Now let us discuss about the sources of data. When you say a data source, this is actually a location. It is a location where data that is being used originates from. So a data source may be the initial location where data is born or where the physical information is first digitized. However, even the most refined data may serve as a source, as long as another processes, accesses, and utilizes that kind of data. So data sources may be a database. A data source may be a database, it may be a flat file or live measurements from a physical device. Let's say there is a machine learning and it measures data in a real time. It can be scrappled web data like the cookies, etc. For example, think of this as a data source. Think of this. Imagine there is a fashion branding selling products online. Then to display whether an item is out of stock, then the website gets information from an inventory database. In this case, the inventory tables are the data sources, which are accessed by the web application, which serves the website to the customers. You have to note that databases remain to be the most common data sources as the primary stores for data in ubiquitous relational database management systems. How about data sources types? Through the diversity of content, let's say we have a content format and location of those data, then it increases with the contribution from these technologies, such as we have a technology called the Internet of Things, and we have the adoption of big data methodologies. So it remains possible for this to classify most of the data sources into two most categories. Because of those technologies that are emerging, then we can have two groups of data sources. The first group is what we call the machine data source that must reside on the machine. That is ingesting data and cannot easily be shared. Like other data sources, machine data sources provide all the information necessary to connect to data. For example, there is such as relevant software drivers or the driver manager, but users need only ever to refer to the data source name, we call it DSN, as the shorthand to invoke the connection or query of the database. We have another data source that we call a file data source. File data source actually contain all of the connection information inside a single shareable computer files. Actually, users do not decide which name is assigned to a file data source, as these data sources are not registered to individual applications or to systems or to users, and in fact do not have the DSN like that of machine data sources. So each file stores a connection string for a single data source. Now, after we have understood data sources, we say the primary data source in most of the data management platforms and data management process, we talk about the database. So it is very important to discuss about the types of databases that exist. We have a centralized database, we have distributed database, we have relational database, cloud databases, object-oriented databases, graph databases, and even intelligent databases. Speaking of centralized databases, the information is stored at a centralized location, and the users from different locations can access this data. And when you talk about centralized databases, that means we can have our data centralized in here, and users from different sources can access this centralized data. This type of data contains applications, procedures that help the users to access the data even in a remote location. So users can access this centralized data even when they are located in remote areas. We have various kind of authentications. We have various kind of authentication procedures that are applied for verification and validation of these end users. Likewise, there is a registration number that is provided by the application procedures, which keeps track and record of those data usage. Apart from centralized databases, we have what we call distributed databases, just the opposite of centralized databases. The distributed databases has contributions from the common databases, as well as information that is captured by local computers also. The data is not at one place and is distributed at various sites of an organization. The sites are then connected to each other with the help of communication links, which helps them to access the distributed data easily. So you can imagine a distributed database as one in which various portions of a database are stored in multiple different locations. We call them physical locations, along with the application procedures, which are replicated and distributed among various points in a network. There are two kinds of distributed databases. We have one which we call homogeneous and another one which we call heterogeneous. The databases which have the same identifying hardware and run over the same operating system and even application procedures, these kind of databases are called the homogeneous distributed databases. For example, all physical locations in distributed databases where operating systems, underlying hardware, as well as application procedures can be at the same but if they can be different at various sites, then distributed databases, which is known as heterogeneous distributed database, is given. Now we have another type of database which we call relational database, which is very common. These databases are categorized as sets of tables where data gets fits into a predefined category. The table actually consists of rows and columns, where the column was an entry for data for a specific category, and rows contains instances for that data defined according to the category. The structured query language, we call it SQL, that is the standard user and application program interface for these kind of databases, where we call relational databases. Leaving aside relational databases, we have cloud databases. Nowadays, data has specifically getting stored. As we can see now, we have some cloud computing databases, like we have Google Drive, we have OneDrive, and so many other cloud computing platforms. So data gets stored over clouds. That is, they are stored in a virtual environment, either in a hybrid, in a cloud, or in a public or private cloud. When we talk of a cloud database, is actually a database that has been optimized, or it has been built for such a visualized environment. There are a variety of benefits that we can get from a cloud database, some of which are that ability to pay for storage capacity and bandwidth on a per user basis, and they provide what we call scalability on demand along with the high availability. A cloud database also gives enterprises the opportunity to support business applications in a software as a service deployment. We have another type of database which we call object-oriented database. Object-oriented database is a collection of object-oriented programming and relational database. There are various items which are created using object-oriented programming languages like C++, Java, which can be stored in relational databases. But these object-oriented databases are well suited for such items. An object-oriented database is organized around objects rather than actions and data, rather than what we call a procedure. So it is organized around what we call the objects. And when we talk of objects, we mean actions and data, or we say events and procedures. For example, think of a multimedia record in a relational database can be definable data object as opposed to an alphanumeric value. We have another type of database, we call it a graph database. Speaking of a graph database, this is a collection of nodes and edges. When you talk of a graph, you're speaking of nodes and edges. Nodes and edges, it means that you have a node and this is the edge, a node and the edge, a node and the edge, a node and the edge. So this is what we call a graph. And it is used to represent an entity, and each edge, this node here will represent an entity, and this edge here, edge will be describing the relationship that exists between those entities. So a graph-oriented database or a graph database is a type of NoSQL database that uses graph theory to store, to map, and to query relationships. So these graph databases are basically used for analyzing interconnections. For example, a company might use a graph database to mine data about customers from a social media. Think of this, for example, we talk of this is a person. We can say a person likes a restaurant, and a restaurant is located in a city, and this person lives in a city. So you see this kind of relation creates a kind of a graph, and that is what we call graph-oriented database. Now we are talking about another type of database which we call it intelligent database. This is a full-text database that employs artificial intelligence interacting with users to ensure that returned items, we call them hits, contain the most relevant information possible. You remember when we were talking of SQL databases, the relational databases, the traditional database where the searching was by the use of keywords and verbatim phrases which were connected by Boolean operations such as the and, the or, and the not. So we were saying maybe select something, this, but when we are talking about intelligent databases, then these ones actually ensure that the returned items contain the most relevant information possible. As we are proceeding to the end of our lecture, let me talk to you about what we call information warehouse. Traditionally, this was called a data warehouse. In a simple definition, we say an information warehouse is a collection of databases in an enterprise across all platforms and departments. Actually, information warehouse is a consolidated system of records for all business information in an enterprise across business functions. It is a single version of truth that gives the business leaders a cross-functional view of enterprise performance. And building an information warehouse involves integrating data from numerous internal and in some external sources. So a warehouse actually collects data from various databases. So it is a kind of collection of several databases in one centralized press. So thank you very much for following Elimika Mtandaoni. My name is Agustino Mogosi. You have been following a series of